So, are you familiar with right angle triangle? Are you familiar with that? So, I hope you are familiar with the right angle
Yes,
triangle.
yes, sir. Yes, yes.
Basically, it is something like this, right? So, this is the right angle, right? And if I draw another one, right, which is also called a right angle triangle, right? And another one, all of these are right angle triangle, right? So, especially we are going to talk about this the relation of this right angle triangle, right? Right angle triangle. Right? Right angle triangle. So we have a right angle here. And also here and here. Here you have right angle and here you have right angle. Right? Apart from that, right? Apart from that, you have two sides, right? Those two sides are attached to the right angle, right? So this right angle formed by using these two sides, right? Here you have the right angle, and these are the two sides that form this right angle. A right angle and two sides. What is the other? What is the
Acute angle,
other?
sir. Acute.
No, no. So what is the other side?
The other side, the straight angle. Ekasiasur. The
Ah,
180.
for this
180.
now for this side, what we call
Straight angle, straight angle. And a straight line, straight line, straight line.
an angle. I am asking from you
A
what we call this
straight
side.
line, straight line,
So
straight
that
line.
straight line is called what? Hypotenuse.
Hypotenuse theorem.
So I am asking the technical word. Huh?
Okay, but
ඒක දන්නවද? So you know that?
ඔව් දන්න සර් පට ඉන්න මට මතක් කරගන්න ඕනේ.
Right. Okay. So I will write something like this. So I will write this is A, this is B and C. Don't write that. Don't write. Look at the board. Right. So ABC angle. So you are putting something like this thing. Upper side of B, ABC angle. Right. ABC angle equals to
Okay, sir.
90 degrees, which is our right
Okay.
angle. And this AC side is called AC equals, so we call AC our hypotenuse. Right? Hypotenuse. So if I draw same thing here, A, B, C. AC is our hypotenuse. A, B, and C. AC is our hypotenuse. Right? So ABC always 90 degrees. So 90 degrees
Yes.
is called right angle, right? Another name for this we call right angle. These are the basic things before we do Pythagorean relation. Right? Please please draw this and write this. Okay. Pythagorean relation, that is our main title, and we are going to talk about the right angle now. Please draw this and let me know. Right. So now we are going to discuss about the Pythagorean relation. Right. Now we are going to discuss about the Pythagorean relation, and that Pythagorean relation has been introduced by a Greek mathematician called Pythagoras. Right. Pythagoras. Right. So that theorem has been named by using his name to honor the mathematician, right? So his name is Pythagoras, and he is a Greek mathematician, right? Greek. So it is mathematics, right? So to honor that mathematician, we have named this relationship with by using his name, right? So basically, the Pythagorean relation. So it's called the Pythagorean relation. So now we are going to discuss the Pythagorean relation. Right? So, so basically, you know what we discussed previously. It is a right angle and it has a 90-degree angle, right? And also it has an hypotenuse, right? So we are going to discuss this theory by using the right angle triangle, right? So basically, uh, let's now discuss about the Pythagorean relation, how it's built up, right? So how it's built is, so I will first draw kind of a right angle triangle, and by using this, I will explain how the relationship has been built, right? So I will say on this side we have a square, right? Something like this. And on this side also we have a square. And on this side also we have a sphere. Right? So I will clear this somewhat. Right? On the hypotenuse, right, we have ABC. Right? On the hypotenuse, we have again a square, right? So I will say, for an example, right? This side equals to this side equals to this side equals to this side. That means this that again a square, and this is also a square. 1, 2, 3, 1, 2, 3, and 1, 2, 3. Right. So I will say the length of this side and AB is 4 cm, right? And BC is I will say 3 cm, 3 centimeters, right? And our AC side, that means our hypotenuse, right? I will say it is 5 cm, 5 centimeters, right? Right. Now, can you tell me? Okay, I will put this square is number 1, and this square is number 2, and this is number 3. Can you say me how to find the area of this number? How to find the area of this number 1 square?
By adding both sides together. 13 plus 30 centimeter plus the 5 centimeter plus 4 centimeter equals 360.
Is it perimeter or area? I am asking.
The area, it's an area.
No, how to find the area of this square?
We need to multiply them both sides.
Yes. We need to multiply one side of the square by the other side, right?
Yes.
Right? We need to multiply one side by the other side in order to obtain the area of the square, right?
Yes.
So, what is the if this AC is 5 centimeters, can you tell me the length of this side? This one?
Huh?
This is the square. Length of this side is 5 centimeters. What would be the length of this side?
5 centimeter.
Yes. This side?
5 centimeter.
This
5
side?
centimeter. 5 centimeter.
Yes. All are 5 centimeters, 5 centimeters, 5 centimeters. Right. Okay. Now, good. Right. So, I am going to write the area of the square number 1. Right. The area of square number 1. Right. So, you know how to find it. Right. So, I can write 5 centimeters by 5 centimeters. So, same, I can write the area of square number 2. Right. And I can write the area of the square number 3. Right. Can you fill this final answer, and for this final answer and final answer? Right. Please draw this and fill the blank. Right. Here also you have a blank. You know how to find the square?
Sir, may I go and drink some water for may I go and drink some water?
Right. The area of square number 1, right? 5 cm by 5 cm. 5 cm multiplied by 5 cm. Right? So that means 5 times 5, 25. Right? centimeters times centimeter. Centimeters, centimeter. Centimeters to the power 2. Right? So the area of square number 2. This is our square number 2 and the length of one side is 4 centimeters. So you know all the other sides are equal to this 4 centimeters.
Yeah.
So you are going to find the square of the area of the square number 2 by multiplying 4 centimeter by 4 centimeter. So you will obtain 4 times 4, 16 centimeter times centimeter, centimeter square. Square
Yes.
centimeter. Right? And the third one, same 3 centimeters times 3 centimeters. 3 centimeters times 3 centimeters. Right? 3 times 3, 9 centimeters times centimeter, centimeter square. That means square centimeter. So this is how you are going to find the areas of
Theorem.
the square number 1, square number 2 and square number 3. Right? So if you get these answers, right, it's correct, right? Now,
Okay, sir.
then I am going to take the addition of 2, square number 2 and square number 3. Right? I am going to take the addition of the areas of the square number 2 and square number 3. Let's see what will happen. Right? So already you know the area of the square number 1, right? This is 25 centimeters now. Right? Now what I am going to do is, right, I will use this space now. I will clear my title as well. Now look at the book. There is a relationship between, right, these areas, right? Areas of the squares, you can build a relationship. If you get the addition of the areas of the square number 2 and number 3, it will be equal to the area of the square number 1, right? Let's see. I am going to take the addition of 2 and 3. And I am going to take the summation of summation of summation of square number area of square number 2 and 3. Right? I am going to take the addition. Right? That means 2 plus 3. Right? So I will write this here 2 plus 3. And summation of areas of 2 and 3 square, right? So basically, it will be equal to 16 square centimeters plus 9 square centimeters. 16 square centimeters plus 9 centimeters. What would be the answer? What is the answer? If I get the addition,
25 to the power of 4.
yes, 25 to the square centimeter, right? 25 square centimeter. That is how you are going to read it. 16 plus 9, it gives you 25 centimeter. Sorry, 25 square centimeter, right? Now, can you find a relationship between this one and this one? Right? If you add the areas of the square number 2 and the square number 3, you will get 25. square centimeter. But right, if you take the area of the square number 1, what it would be? It is also 25 square centimeters, right? So that is the relationship, right? So finally we can write, right? Finally we can write this area we obtain, right? This area we obtain is equal to the area of square number 1. So now we know if we get the addition of the areas of 2 and 3, it will be equal to the area of the square number 1. So that is what we call here, right? But we have written here, right? And please write this. Here you have 2 plus 3, 2 plus 3. If you can see, this is 2 plus 3. Summation of areas of 2 and 3, 16 square centimeters plus 9 centimeters square centimeters, which is equal to 25 square centimeters. And here, this is important, right? This 25 square centimeter equal to our area of the square number 1. Please write this.
The finish.
Right. Give me a minute. Right. So I am going to clean the board. Before that, I will clean this one. I will clean here. Right. Okay, now look at the board. So, therefore, we can write down this relationship between these squares, right, in our words. So, now I am going to write the relationship between these squares, right, like below, right. Now, look at the board and try to understand. Relationship between here, right? So what is the relationship? As I told you before, so you know the area
Yes.
of number one. Yeah.
Yeah.
Right? The area of sphere number one equals, right? The area of sphere number one equals, right? The area of sphere number two plus the area of sphere number three, right? So this is the relationship between these or among these three spheres. The area of sphere number one equals to the summation of, right, area, sorry, sphere number two and sphere number three. That means the area of sphere number two plus the area of sphere number three. Guys, please write this and let me know.
Okay, sir. Okay, sir. Excuse me, sir. Sir, I think someone joined.
Yeah. Yes, guys.
I think someone joined.
Sorry.
I think someone joined because it shows me like a name called Oshada.
Yeah. I know. He's one of my cousins, right? Please write me and let me know.
Sir, finished. Finished. Sir, finished. Finished.
All right. Okay. Right. Okay. Now we can write down the Pythagorean relationship, right? So I will share the screen, right? Instead of writing in the board, right? I will type it in the screen, right? So I want to save my time. Right? Can you see the board? Can you see?
Yeah. Yes, sir.
Right. Okay. So this is the Pythagorean relation for a right angle, right? So this is
Yes.
how we are going to express the Pythagorean relation, right? So please write this Pythagorean relation for right angle, right? Can be expressed as below, right? Pythagorean relation for right angle can be expressed as below, right? So our Pythagorean relation is the area of square drawn on the hypotenuse, right? The area of the square drawn on the hypotenuse of a right angle triangle is equal to the sum of the areas of the squares drawn on the remaining two sides. So this is what we did.
Yes.
So please write this and let me know.
Um, okay, sir, finished.
Right, done, right?
Yes.
Right,
Sir.
okay. So I will explain again. One, this is our number two, and this is our number three. A, B, and C, right? So these are our remaining two sides, and this is called hypotenuse, right?
Yes.
Okay. Now you know how to find the square of the area of the square number one, right? How do we write area of the square number one? By looking at this picture, right? One side is given AC, right? The length of the hypotenuse is AC, and how do we express the square? Area of this square number one in a different way by using AC, right? So we can say multiply length of AC by the same length, right? That means we can express the area of the square number one, right? Like this. AC times AC, right? AC times AC. So this is the length, hypotenuse length. AC times AC, right? Equals to AC square, right? Equals to AC square, right? Likewise, you can express the area of square number 2 and area of the square number 3 by using AB and BC respectively, right? By using AB and BC. So let's see how to express the area of square number 2, right? So length of the one side is of square number 2 is AB, right? So all the length of the square number 2 is equal together. That means AB, 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 right? AB, 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 AB. All lengths are equal, right? So by looking at this, we can write down the area of square number 2, AB times AB. AB multiplied by AB. That means AB square, right? AB square. Right? And by using the same way, you can write down the area of square number 3 as well, right? By using BC. So this length is BC. So this is an square, and also this side is equal to BC, and this side also BC, this side also BC. Same length. So how do we express the area? BC times BC. That means BC square, right? So if you apply the Pythagorean relation that I previously told you what to double. How do you make the relationship? Area of 1 equals to summation of area of 2 and 3. That means we can say according to the Pythagorean relation. According to the Pythagorean relationship, right? We can write 1 area of 1 equals to area of 2 plus area of square number 3. That means by looking at this, right, you can write area of 1, AC square, right, equals, so that is, this is our area, AC times AC square, right, AC square, and area of 2. Area of 2 is AB square plus area of 3. Area of 3 is BC square. BC times BC. BC square. Right? So this is our Pythagorean relationship. This is very important. Huh? Very, very important. You need to remember it. Right? Make a පාඩම් කරගන්න. පාඩම් කරගන්න means you need to know how to write the Pythagorean relationship when you are given this kind of a right angle, right? Let's practice, right, some more, right, by looking at the right angle. So you need to write down the Pythagorean relationship like this, right? AC square equals AB square plus BC square, right? I will let you know how to do this. Please write this. Draw the picture. Right? First of all, draw the picture, and then write down this, and let me know.
Okay.
Right, now let's practice this. Right. So I need to make familiar this to you. Right. So let's practice more. So once you see something like this, right? So this is the right angle. Right angle triangle, right? In anywhere, right? Poet here, right? If you see something, I will draw this again. Here there is a pattern, right? There is a pattern, right? Try to catch the pattern, right? Always try to catch the pattern when you have something like this. And I will draw first. First of all, look at the board. Look at the board, and this is a right angle triangle, right? Example number 1. This is our example number 1, and this is the right angle triangle, right? And this is our hypotenuse, right? And I will say the length of the hypotenuse is A, simple A. The other two sides I will say B and C, right? So these are the lengths, right? So these are the lengths A, B, C. By looking at this, right? In your exam paper, they will ask, write down the Pythagorean relationship for this right angle triangle. Write down the Pythagorean relationship for this right angle triangle, right? Now at one, what you need to remember is this is our hypotenuse. Take the hypotenuse first as according to this, right? So I will take this. So I will say like this. This is A, this is B, and this is C. So by looking at this equation, I am going to, right? I am going to substitute. I am going to substitute what is AC squared, what is AB squared, and what is BC squared. Right. So basically, this is the way you are going to apply the Pythagorean relation. Right. What is the length of hypotenuse? What is the length of hypotenuse? Guys,
Yes sir, මේ hypotenuse length එකද?
what is the length of the hypotenuse?
Hypo?
What is the length of the hypotenuse? By looking at the picture.
Adrial axis nේද sir?
So length
Adrial.
of the hypotenuse is A, right?
Yes. Sir,
Length
ඒකෙන් තේරුම් කරන්නේ adrial axis එකද?
AB is B. Length of
Yes.
this BC side is C. So I am going
Yes.
to use this length to find our area of the square, right? So that means basically you can apply AC square, right? AC square means length of AC. Length of AC means A, right? A square equals. This is how you are going to apply the Pythagorean relationship, right? Equals AB square. AB square. AB square. That means length of AB is B. So you have to take B times B. That means B square. Right? Plus BC square. BC square. BC is this. And what is the length of BC? It is C, right? C. So BC square means BC times BC. That means C times C. C times C. C times C means C square. Right? So this is the Pythagorean relation for this triangle. Right? And example number 2. Example number 2. I will write different one. And A, B, C. This is our right hand. Right? And I will say length of the hypotenuse. If not, I will say length of AC is Z. Z. And length of AB is X. And length of BC is, I will say, Y. Now, how you are going to apply the Pythagorean relation? How do you apply it? By looking at this. Right? So first of all, AC squared. AC squared means the length of the hypotenuse should be multiplied by its length, right? Hypotenuse times hypotenuse. That means hypotenuse is AC. The length of hypotenuse or length of AC is Z. That means Z square equals the square of summation of the squares of the other side. That means length of AB. AB square. What is AB? Length of AB is X. X square plus What is the length of BC? BC. Length of BC is y, right? That means y square, right? So this is the Pythagorean relationship for this ABC triangle, right? Now I will take another example. Example number 3. A, B, C, right? So I will say this side is 4 centimeters. So I will say this side is 6 centimeters, right? And I will say this side is 10 centimeters, right? Now I am going to apply the Pythagoras theorem, Pythagorean relation for this example number 3, right? Now look at the row. So try to remember this: the hypotenuse square, and the summation of other two sides length, right? Square to the uh, length of square of length of the other two sides, right? And get the summation for that, right? Now look at the board now. Try to catch the pattern. So first of all, I am going to take the hypotenuse, right? In order to apply the Pythagorean relation for this ABC right angle triangle, right? This is 10 centimeters, right? So I am going to apply this like 10 centimeter times 10 centimeter. So first of all, we need to get this, right? That means 10 centimeter into 10 centimeter. If you know how to apply it, you can write it within 10 seconds, right? So 10 centimeters times 10 centimeters. That means 10 times 10. That means 10 to the power 2, right? 10 to the power 2. Centimeters times centimeter. Centimeters to the power 2 is square centimeter, right? Right? Square centimeter equals to the square of the other two sides, right? Summation of the square of the other two.
10 to the power 4 centimeters.
No, 10 to the power 4, no, not right. That is not. 4 to the power 2 centimeters to the power 2 plus 6 to the power 2 centimeters to the power 2, right? This is the way that you are going to apply, right? Please try to get the pattern now. Now look at the board again. First of all, take the hypotenuse of the right angle triangle, right? Length of it is A. So A square equals B square plus C square. D square plus C square, right? And this one, what is the hypotenuse? This one is the hypotenuse, right? This one is the hypotenuse. So what is the length? Is it, right? So then take Z square, right? Z square equals x square plus y square. X square plus y square. Very easy, right? Come to the third one. What is the hypotenuse? 10 centimeters, right? 10 to the power 2 square. Other two sides, 4 centimeters. That means 4 to the power 2 centimeter to the power 2. That means square centimeter plus 6 to the power 2 centimeter to the power 2. So very easy, right? So please write this and let me know. I have changed the length of this side and this side to the 6 and 8. 6 and 8.
So finished. I
Right,
fixed the
okay.
correction.
Now let's do some examples first. Hmm. Let's do some examples first. Right. I hope you can see the screen. Right. Can you see the screen?
Yes, sir.
Right. Okay. Shall we do the first one? This and this.
Sure, sir. Okay.
Write the Pythagorean relation for each right angle triangle using the given length. These are the lengths. P, A, R, and X, Y, Z. Right. So first of all, you need to identify the hypotenuse. That is the that is the side which is in front of the right angle. Right. Right angle in front of the right angle, you can find the hypotenuse. Right. So you are going to begin with hypotenuse. Once you finish, let me know. Right.
Sir, මට තේරෙන්නේ අර first one එකයි fourth one එකයි.
First one nege, fourth one nege.
ඔව් sir.
So I asked you to do first one and second one only. Did you do these two?
පුළුවන් විදියට කරා sir.
එකෙන් තේරුම් නැද්ද? පුළුවන් විදියට කරා
නෑ
කියලා.
ඒ ටික මට ඒ කියන්නේ පොඩක් පැටලුණා. පොඩක් sir කියලා දෙන්න පුළුවන්ද? මට first one එක විතරක්.
So I will write down the answers here, right? So
Okay sir.
you are going to apply the Pythagorean relation. So that means, so you need to identify the hypotenuse first. Kalan ඔයා ඉවරද? All right. So first of all, we need to identify our hypotenuse, right? So by looking at this, right, first one, what is our hypotenuse? That is P, right? So if we apply the Pythagorean relation, how do we do this? First one, so P squared equals, right, A squared plus R squared.
R square.
Right. A squared plus
R square.
R squared. I will tell you a short way, right?
Yeah.
So for the second one, I will do the same, right? This is our second one. What is the hypotenuse? What
The
is
hypotenuse is x.
X, right?
X.
Oh, now look at the board. Look at the screen now.
Okay sir.
I'm going to tell you the relationship like this. X equals z plus y. Right? Z plus y. So what you have to do? Take the square of all terms. Right?
Okay, sir.
So this is the Pythagorean relation. Right? This one and this one. For the first one and the second one. And try to do third one and fourth one.
Okay, sir.
You need to identify the hypotenuse first.
Okay, sir.
And let me know once you finish.
Sir, finished.
Right. So how did you do third one?
The third one, sir, 10 times 10 equals to the power of 2 equals 6 to the power of 2 times 8 to the power of 2. Say,
Alana, can you say this?
Fourth one,
This one?
10 square centimeter, 10 square 2 square centimeters equal to 8 square 2 square centimeters plus 6 square 2 square centimeter. Sorry, square centimeter.
Yes, yes. So if you are going to write down the full answer for this one, right? So you need to first identify your hypotenuse. So your hypotenuse is 10 centimeters length, right? In length. So you have to get the square of 10 centimeter. 10 to the power 2 centimeter to the power 2 equals and 8 and 6. So 8 cm plus 6 cm. That means you need to get the square of these two as well. So this is how we are going to write down the Pythagorean relationship for the third one, right? And let's go to the fourth one now, right? So what is the hypotenuse? Y centimeter. So I will write it as it is. Y centimeters equals 3 centimeters plus x centimeters. Is this right? Is this correct?
No,
No, right? So you have to get the square, right? Of
yes.
each and every term. Right? That means y square, right? Square centimeters equals 3 square centimeters plus x square centimeters, right? So you have to write like this. So these are the full answers. Centimeter to the power 2 is needed, right? That is essential, that is important, right? Okay. So let's move to the next exercise. Try to catch the pattern, na? Always you have to begin from your hypotenuse and you have to get the summation of the squares of these two. Hypotenuse, summation of squares of these two, right? Hypotenuse, summation of squares of these two. Hypotenuse, summation or the addition of these two of the squares, right? And let's move to the next one. It says you need to fill in the blanks, right? So try to fill the blank for the first one, second one. Okay. Only do these two. Firstly, first one and second one. You have to rewrite AC squared, AB squared plus. So you have to identify what length should be here. And PR squared, something plus something. So you need to identify.
Sir, the AB plus the plus equals CB to the power of 2.
Yeah.
Square.
Please do. Once you completed this, let me know. Right, done.
Yes, sir. Yes.
Right. Right. So what is the answer for here?
The CB to the power of 2, not to the square.
Yes.
CB.
AC squared, AB squared,
CB.
BC squared, right? BC,
BC. Okay.
right? And here,
QR. No. QP plus QR.
right? So that is not the full answer. PR squared, that means this PR squared, PQ squared, QR squared to the power 2 is essential, right? Right. So those two are okay. Right. Now try to do this one. Third one. Right. You need to, right, keep watching. Right. You need to carefully watch. Right. Carefully see to identify the right angle triangle A, B, C, D. So there are 4 triangles, 1, 2, and 3, 4.
Yes.
And in this side you have hypotenuse. In this side you have hypotenuse, and you have to fill the blank.
Yes, sir.
Right. Please let me know once you finish. Now look at the board. Right. I will draw the question. Huh? It is something like this. Right. It is something like this. In your question, right? It is something like this. So we have basically here you can identify four right angle triangle, right? I will say AOD. AOD is the first right angle triangle, right? AOD and AOB. This is my second right angle triangle. BOC, right? BOC. My third right angle triangle, right? COD. That is my fourth right angle triangle. So only these four right angle triangles can be identified, right? So you are going to apply Pythagorean relation to the first one, to the second one, to the third one, to the fourth one separately, right? So I will explain this furthermore. AOD. So this is my AOD. AOD. This is my AOD right angle triangle. That means my first one. Right? This is first right angle triangle, this upper one. So how do you apply the Pythagorean relation? What is your hypotenuse? Hypotenuse is AD. AD square equals AO square plus OD square. Right? Try to catch the pattern now. Make a pattern, right? Always you need to identify the right angle triangle, right? For this hypotenuse. And then you need to write this. Hypotenuse square AD square equals AO square plus OD square. Right? Very easy. Second one. This is our second one. Right? Second right angle triangle. That means AOB. AOB. Right? So I will draw it. Right? Look at the board. What way? Like a pattern of making identify and bond. How do you find the pattern? Right?
Oh, sorry.
AOB. So I will write it as it is. This is A, O, and B. Right? A, O, B. This is my second one. Right here. So how do you apply the Pythagorean relation? What is the hypotenuse? Hypotenuse is AB. That means AB square equals AO square BO square. Right? Very easy. Right? Third one. Third one. Third one is this. Right? So I will draw it. It is something like this. Right? B, B, C, and O. BCO. Right? So what is the hypotenuse? BC. That means BC square equals BO square plus OC square. BO square plus OC square. Right? Very easy. Fourth one. So this is my fourth one. Fourth right angle triangle. Right? It is something like this. Here O, B, and C. So what is the hypotenuse? Hypotenuse is BC. Right? BC square equals OC square and OD square plus OD square. Mixture again, that's all. Right? So this is what you need to identify.
Okay, sir. Okay.
So
I understand.
now you can fill the blank. Right?
Okay, sir.
Right. I will again share the screen. Right, let's do third one. Right. It says, right, identify all the right angle triangles. First you need to identify the right angle triangles in each figure given below and write the Pythagorean relation. Right. First you need to identify the right angle triangles. Then you need to write down the Pythagorean relation for each and every triangle. So I will do the first one. Right. Then you have to do second one. Right. So in the first one, right? In the first one, first of all, I am going to identify the right angle, right? Right angle triangle, right? So first of all, I will identify my right angle as x, y, q. X, y, q. So that is my right angle triangle, and I will highlight it like this. Right? This is my first right angle triangle. Right? Right? That means x, y, and q. XQ is the hypotenuse. Right? X, y, sorry. X, y, q. Right? This is my right angle triangle. First right angle triangle. Right? This is my first one. And I am going to apply, no, I am not going to apply, and first of all I will try to identify my right angle triangles first. So XYQ is one of the right angle triangle that I have in this picture, right? Now I am going to identify another right angle triangle by looking at this, right? I will use, so this is my right angle. So based on this, I will have to identify PY, YZ, PZ. This is my second right angle triangle. So I will write it PYZ. So that is my second one. PYZ. Right? That is my second right angle triangle. So do we have any other right angle triangle? Yes. Right? So what is that? I can say the bigger one, right? X, Y, Z. Right? So this is the biggest one, right? X, Y, Z. This is my right angle triangle. This is my right angle. This is XZ is my hypotenuse, right? So my third one is X, X, Y, Z. So these are my three right angle triangle I can find from the first picture, right? So now I am going to apply either the Pythagorean relation. So I will apply for the Pythagorean relation for the XYZ first. So this is my XYZ, X, Y, Z. This red triangle, right? You know how to apply. First you need to find the hypotenuse. What is the hypotenuse of this XYZ right angle triangle? What is it?
The hypotenuse is x no XC.
Yes,
XC.
right? XZ is the hypotenuse of the XYZ. So I will write XZ squared equals the other side XY and YZ, right? XY square plus YZ, right? Square, right? So that is how we are going to apply the Pythagorean relation to the XYZ right angle triangle, right? Now I am going to apply the Pythagorean relation to my PYZ right angle triangle. So I will let you know. I will show it to you again. I will draw PYZ, PYZ, right? This is the second right angle triangle that I am going to apply my Pythagorean relation, right? So what is the hypotenuse of this PYZ right angle triangle?
PZ.
PZ, right? PZ squared equals Squares of other two sides, right? Py and yz. That means py squared plus yz square, right? So this is the second one, right? Okay, I will clear this one. Now I am going to apply my Pythagorean relation to xy cube. So first of all, I will highlight it for you. So xy cube, x y cube. So this is my first right angle triangle, right? So what is the hypotenuse of xy cube right angle triangle?
X cube.
X cube, right? X cube to the power 2 equals to the other two sides.
PQ. No.
Xy
XYZ.
xy squared plus y cube
YQZ.
y cube square, right?
So why won't the C comes? The Z?
Huh?
No. Why won't the Z won't come?
So we are going to apply the Pythagorean relationship for xy cube ni. This highlighted one ni. So Z is out of the scope ni. So previously we apply xyz ni.
Yes.
So we have taken xy cube triangle only. We are not going to care about these things,
Okay, sir.
right? So that is why we are not going to use z, right? This is our triangle, ni. This is red one. Ni. So basically, these things won't come, right?
Yeah. Yes, sir.
This part is cancelled. So we are taking only xy cube right angle triangle, right?
Yes.
So that is why we are not going to use z. So x cube is the hypotenuse. And the other two sides are xy and y cube for this one. And py z, when it comes to the py z, so it is something like this. Right? Py z. Py and z. So this is our right angle triangle, py z. We are not going to care about others. Right? We are not going to take care about x. අපිට මේවා වැඩක් නැහැ. Now we are going to consider pyz only. This is our right angle triangle. So now we are applying Pythagorean relation pyz. Right. Likewise, you have to do this one, second one, right? And please write this for the first one. This is the way. You have to follow it in the second one as well, right? First, draw this picture and write down this 1, 2, and 3. Right. For today, I'm going to wind up the class from here, right? So, homework is rest of, yes. Are you? Homeworks will be, okay, I will put to the group,
Okay, sir. Okay. Okay, sir.
So you need to do the homework and send me my inbox.
Okay, sir. Sir, okay. Okay, sir.